All right, let's take a look at lesson 6, and it's dealing with transformations and all of them together, which you're very familiar with. I want you to recall from lesson 1, when we had a function, a represents a vertical stretch by a factor of a, b represents a horizontal stretch by a factor of 1 over b, c was a horizontal translation going c units right. It's the exact same thing with trig, but we now call it a horizontal phase shift. So it means the same thing as a horizontal translation. And D was a vertical translation, D units up. Well, we now call it vertical displacement. And again, it means the exact same thing. It's just different words in trig. So let's take a look at a couple of examples. Here, as we can see from up here, it indicates a horizontal translation, but again, we're going to call it a horizontal phase shift. So we're going to say horizontal phase shift 30 degrees right. And we remember from transformations, the sign is kind of opposite intuitively to where we would go. Now we have, with part B, another horizontal phase shift. And that's 60 degrees left. But we also have a D value here, so that'll be vertical displacement. Two units down. All right, C is a little bit different. It's a little bit unorganized, so I'm going to get it organized first. I'm going to add 55 to both sides, and we end up with y is equal to sine x minus 90 degrees plus 54. So this is a horizontal phase shift. $90 degrees right, and a vertical displacement. $54 units up. All right, next part, we're just going to write the equations now. So we have a cosine function with a horizontal phase shift of 75 degrees to the right. So we know your base function looks like this. So we just have to indicate it with a shift of 75 degrees to the right. So our equation is going to look like that. All right, now we have a sine function, and again, my base sine function looks like this. So we just have to indicate the transformations. So we have a horizontal phase shift, 2 pi over 5 left, and vertical displacement 3 units up. And if it's up, we go up 3, so we plus, and if it's to the left, we also indicate that as a plus. All right, I'm going to do one of these, and then I'm going to leave it up to you. Oh, I'm going to do 2 of these, and then I'm going to leave it up to you. All right, I'm going to do A, and I'm going to do C. So we're asked to find the amplitude, period, horizontal phase shift, and vertical displacement of the graphs of the following functions. Amplitude is simply my A value, period, is equal to 2 pi divided by B. So I'm just going to clean that up. My B value here, even though there's not a bracket, we can assume there's a bracket here if it helps. It's going to be 2 pi divided by 1 over 4, which is equal to 8 pi. Horizontal phase shift, this is pi over 6 radians. I better indicate what it is. Horizontal phase shift pi over 6 radians right, and your vertical displacement is 5 units up. Sorry about the lack of room there. Now, part C is a little bit different. Actually, let me do part B because it's a little bit more tricky. If we go back up here, when I talked about this function here, if you recall in transformations, and I'm just going to give you a little example up here, if I had y is equal to f at 3x minus 6, we would read that as a horizontal stretch by a factor of a third. But what we needed to do, and if you recall, is we needed to factor out that 3 to be able to read the translation correctly. So that follows suit with what we got to do here. All right, so my amplitude is equal to 4. The period is equal to 2 pi over 3. And you're probably wondering why I do it in radians all the time. Typically, we do most of these problems with radians. Now, I need to rewrite this equation to get the right horizontal phase shift. So I'm going to go and factor out that 3, because remember that x can't have a coefficient when we are reading horizontal translations. So I rewrote it, factoring out that 3, and this is my resulting equation. So now I can say there's a horizontal phase shift of pi over 3 radians left. And finally, we have a vertical displacement of 2 units down. All right, I'd like you guys to give C and D a try, and I'll be back.